Good day everyone, and welcome to this series of video lesson demonstrating the conversion of Hindu-Arabic decimal numbers to Babylonian cuneiform sexagesimal system. Do you wonder how to convert 678 to these characters and 534,609 to these characters and vice versa? If yes, then please join me in this video series. And please pause this video to read the following objectives. At the end of this series, the student and teacher would be able to appreciate the existence of the discovered sexagesimal number system, which had been evident in our measurement of time and angles. And then each one will find the self-discipline and curiosity in decoding ancient and modern language scripts as a platform to appreciate humanity in the richness of its culture and creativity, and to practice the mindset that learning writing systems can bring harmony to our global community. First, let's convert Hindu-Arabic decimal numbers to Babylonian cuneiform sexagesimal numbers. So first, we're going to transcribe the numbers into the sexagesimal system. And step 2, we're going to translate and decode into the Babylonian cuneiform numerals. What is the sexagesimal system? So it is a number system with a base of 60, where each place value is a power of 60. So here are examples of numbers in base 60. So we have 60 raised to the exponent 4. Then we have 60 cubed. We have 60 squared. Then we have 60 raised to the exponent 1. And we have 60 raised to the exponent 0, which is just equal to 1. Now let's compare the decimal system and the sexagesimal system based on their place values. So here are the place values of the decimal system and their corresponding factors of base 10. So the units place, the factor is 10 raised to 0, that's equal to 1. So we just have n times 1, right? So the digit at the units place is 4 for the number 5,934. Then we have the tens place. The factor is 10 raised to the exponent 1. So for the number 5,974, the digit at the tens place is 7. 7 times 10 is 70. So the value contribution at the tens place is 70. Then in the hundreds place, the factor is 10 squared. So for the number 5,974, the digit in the hundreds place is 9. So we have 9 times 10 squared. We have 9 times 100. So that's 900. And then in the thousands place, the factor is 10 cubed. For the number 5,974, the digit in the thousands place is 5. So we have 5 times 10 cubed, or 5 times 1,000. So we have 5,000. Then adding everything together, 5,000 plus 900 plus 70 plus 4, we have 5,974. On the other hand, for the sexagesimal system, here are the place values and the corresponding factors for each base 60. In the units place, the factor is 60 raised to the exponent 0, which is just exactly equal to 1. For the number 5,974, the digit in the units place is 34. 34 times 1 is 34. Then in the 60s place, the factor is 60 raised to exponent 1. For the number 5,974, the digit in the 60s place is 39. 39 times 60 raised to exponent 1, so 39 times 60, we have 2,340. And then in the thousands of 60s place, the factor is 60 squared. With the number 5,974, the digit in the thousands of 60s place is 1. So we have 1 times 60 squared, so that is 3,600. And then in the hundreds of thousands of 60s place, the factor is 60 cubed. For the number 5,974, the digit in the hundreds of thousands of 60s place is 0. So we have 0 times 60 cubed, that is only 0. So adding these values together, 0 plus 3,600 plus 2,340 plus 34, we have 5,974. You might be wondering on how to find the digits for each place value, so please watch until the end we'll break down the steps for the procedure of finding these digit values. So step number 1, determine the highest place value. So identify the highest power of 60 less than or equal to the given number by comparing them to the powers of 60. So for the number 534,609, which has 6 digits, it is less than 60 to the 4th, but greater than 60 cubed. Therefore, we start with the place value of 60 cubed, hundreds of thousands of 60s, and do not use 60 to the 4th. Again, in determining the highest place value for 534,609, its highest place value is 60 cubed, since 534,609 is less than 60 to the 4th, and 534,609 is greater than 60 cubed. We're going to divide by the highest power of 60. So divide the number by the highest power of 60 to find the digit for its place value. Example, 524,609, our given number. So divide it by the value of 60 cubed, which is 216,000, and the quotient is 2. Thus, the digit at the hundreds of thousands of 60s place is 2. Next, calculate the value contribution of the current place value. So multiply the quotient obtained in the previous step by the value of the current place value. So 2 times 216,000, we have 432,000. So this product represents the value contribution of the digits in the 60 cubed place. Step number 4, subtract the value contribution from the given number. To subtract the value contribution from the given number to find the remainder. So for our example, our given number is 524,609 minus 432,000. The difference is 102,609. So our current remainder is 102,609. The process for the next highest place value. So use the remainder to determine the digit for the next lower place value. So our current remainder is 102,609 divided by 3,600, the value of 60 squared. The quotient is 28. So the digit for the 60 squared place value is 28. Step number 6, calculate the value contribution and subtract for each subsequent place value. The digit at the 60 squared place value is 28. So multiply 28 by the value of 60 squared, which is 3,600. The product is 100,800. Now let's compute the remainder by subtracting 60 squared place value contribution of 100,800 from the previous remainder of 102,609. The difference is 1,809. So this is now our remainder to be used for the next lower place value. As we continue the cyclic process up to the units place, we continue dividing and subtracting for 60 to the power of 1 and 60 to the power of 0 or until the units place. So here in our example, our current remainder is 1,809 divided by 60. The quotient is 30. Alright, so 30 is the digit for the 60th place. Then we compute the place value contribution of 60 digit 30. So 30 times 60, that's 1,800. Then we subtract 1,800 from the current remainder of 1,809. And the difference is 9. So 9 will be the digit in the units place. Alright, so the final sexagesimal digit for the decimal number 524,609 are 2, 28, 39. So write the digit for each place value in the sexagesimal system and then separate each digit with commas. So this is the sexagesimal notation, 2, 28, 30, 9. So when given this notation, we calculate or we convert to the decimal numeral by using this formula. So 2 times 60 cubed plus 28 times 60 squared plus 30 times 60 and 9 times 1. For the summary, we have a simplified version for this procedure. So we have the cycle for transcribing base 10 numbers to base 60 numbers. So first, determine the highest place value. by dividing the number by the highest power of 60 to find the digits for that place value. Then record the quotient, because that quotient again is a digit for such particular place value. Then next, we're going to calculate the value contribution by multiplying. Then next, we subtract the value contribution. So subtract the value contribution from a remainder, from the current remainder. Then repeat for the next lower place value. Alright, so repeat the cycle and the process ends when the remainder number is less than 60, representing the units place digit. After having the sexagesimal number notation, then we are now ready to translate to Babylonian cuneiform numerals. So thank you so much for watching this video, and I would like to thank also the authors of the book History of Mathematics. We have Mr. Bondok, Mr. Villa, and Dr. Powilin for writing such a very inspiring book, and of course Rex Bookstore for publishing or printing the book. So again, thank you for watching, and I hope that you have learned something